Welcome to the Journey Shake Chem. Today's warm-up are some practice of the things that we've been doing. So please do the best you can, and I'll see you in a moment. In number one, we're determining two things: the change in the vapor pressure of the solution as well as the new vapor pressure of the solution. Well, in order to get the change in the vapor pressure of the solvent is equal to the mole fraction of the solute times the pure vapor pressure of the solvent. And I must get the mole fraction. And therefore, I must change my grams of my solute to moles. And sodium chloride, we always have to get the formula. Sodium is +1 and chloride is -1. Sodium has an atomic mass of 23, chlorine is 35.5, and there are two oxygens. And of course, I write them again, and then I add them up, and I get a formula mass of 90.5 grams per mole for the sodium chloride. And when I do the math here, I get 0.1657 moles of my sodium chloride. Now, mole fraction means that I must get my total number of moles. And I am given that I have 75 grams of water, and I must change them to moles. Now, I don't think that I have to give you the molecular weight of water. 1 mole of water is 18.0 grams of water. And therefore, I have 4.1666 moles of water. And I must add them together. And I get 4.3323 total moles. And then I'm going to apply that to my equation. I want the moles of my solute. Remember, it's the change in the pressure of the solvent is equal to the mole fraction of the solute times the pure vapor pressure of the solvent at that temperature. Well, I take my 0.1657 moles of my solute and I divide it by my total moles. And this number then will be 0.03824, my mole fraction. And remember, on the assessment, you will be asked the moles of the solute, the moles of the solvent, the mole fraction of the solute, the mole fraction of the solvent. And these are always intermediate questions, and therefore you must take it 4 significant places and cut it off. Then I multiply it by my pure vapor pressure of the solvent at that temperature, and it is 16.1 kPa. Now, the number that we were given was 55, and therefore 50 degrees, the pressure is 12.3 kPa. And 60 degrees, the pressure is 19.9 kPa. And I must add them together, and that comes out to be 32.2, and I divide it by 2, and I get my 16.1 kPa as my pressure. And when I multiply those two numbers, I get a change of 0.6156 kPa is the change in the vapor pressure. Again, this is an intermediate answer. Then to get my new vapor pressure, which is my final answer, I take my 16.1 and I subtract the 0.6156, these are all kPa's, and I get a new vapor pressure of 15.4844. I look back to my original problem and I see that my answer should have 3 significant digits, and the 8 rounds the 4 up, and I get 15.5 kPa as the answer for my new pressure, vapor pressure of the solution. So I had 2 answers here: the change in the vapor pressure, which is not significant digit rules, and the final answer, which does follow significant digit rules. And that's how you do number 1. 2 is a boiling and freezing point type of problem. And first we know that the change in the temperature of the freezing point is equal to the molality times the freezing point depression constant times the number of particles. And the boiling point equation is very similar to this. And therefore I must get molality. And so I change my grams of my solute to moles. And 1 mole of lithium chromate has a mass of 129.8 grams. We have 2 lithiums, 1 chromium, and 4 oxygens. And remember, we make mistakes on this part, so you might want to write it out. Very, very important. Sometimes we just have to learn the hard way, but I'm hoping you aren't like that. So anyway, we get the number of moles of my lithium chromate, and I get 0.1733 moles of my lithium chromate. Now I'm going to erase some of these materials so that we can have room to write out this information. The change in the temperature of the freezing point is equal to the molality times the constant times the number of particles. Well, I need to get molality, and I only have moles there. And therefore, I must divide it by the volume, the kilograms of solvent. And I have 200 milliliters. Well, when we're talking about water, 1 milliliter is 1 gram. And there are 1,000 grams, 1,000, not 100, grams in 1 kilogram. And therefore, this number is 0.2 kilograms. And when I solve this, my molality is equal to 0.8665 molal. And we'll use that in both of the equations. And the constant for the freezing point depression would be 1.86 degrees Celsius per molal. Now the lithium chromate that we have here is going to dissociate into its ions. And we get 2 lithiums and 1 chromate. This chromate is a polyatomic ion. It stays together as a unit. It can't just break apart. And therefore, we have 3 particles. And when I multiply this out, I get 4.8350. And water normally freezes at 0. And freezing point goes down. And therefore, I have 0 degrees Celsius minus 4.8350, which gives me negative 4.8350. For freezing point, I use regular significant digit rules. And I go back to my original problem. And I have 3 significant digits. And therefore, this 5 will round the 3 up. And my final answer is negative 84 degrees Celsius. And then we have the same form of this formula, but we're using boiling point information. And we have a molality of 0.8665 molal. We have a different constant, and the constant is always based on the solvent. Very, very important point. We have 0.512 degrees Celsius per molal, and we have 3 particles. And therefore, for boiling, I have 1.3309 degrees Celsius is my change in the boiling point. And water normally boils at 100. And therefore, we have 100, boiling point goes up, plus 1.3309. We get 101.3309. And boiling point, you'll recall, has a very special way that we handle these numbers. We go 3 places after the decimal, rounded. And therefore, my final answer is 101.331 degrees Celsius. And that is the boiling point of this solution and the freezing point of this solution. And remember, the constants are always based on the solvent. And that's how you do number 2. Now today we're just going to work on some more problems, and tomorrow we'll get the review sheet, we'll go over the review, and then we'll be ready for the assessment. I know you do well. We've been working hard on this information, and then we'll only have one topic left. Aren't you excited? I'm so excited, and actually I can't wait to see you tomorrow. Bye!